calculate 1 plus cos x, then it will be 0 to 1 plus cos x to 2. Okay, so it will fluctuate between 0 and 2. So this limit does not exist. So we cannot calculate L'Hopital's rule, but can we apply again? I mean, is this in indeterminate form now? Limit extending to infinity f dash x by z dash x. What we get here? We get here 1 by 1 plus cos x. Now this is not in indeterminate form, right? Here at the numerator there is 1. So this is neither in 0 by infinity form or 0 infinity by infinity form or 0 by 0 form. So it is not an indeterminate form. So we cannot apply L'Hopital's rule on this thing. And moreover, this limit does not exist. So the function with which we begin with, we cannot apply L'Hopital's rule here. Okay, is it clear? Okay, now someone is asking what happened if extending to 0. So can you tell me what happened if extending to 0?
You can get the function and apply L'Hopital, do the limit ourselves, right?
Can you speak little louder? I cannot hear you properly.
I just saying we just split it x by x and plus x by sin x.
You are saying for extending to 0, right?
Please correct the question. Correct the question. Sorry, wrong question.
So if extending to 0, what happens to this function?
So extending to 0, then we can divide both numerator and denominator by x, and then sin x by x is equal to 1, and 1 by 1, this is 1.
Exactly. So you can calculate the limit here, but can we apply L'Hopital's rule? I mean, limit you can calculate in any way without using L'Hopital rule. That is okay. What you are saying, you just divide it in x on both numerator and denominator, and you will get this. So this will tend to 2, so it will give you half.
Yeah,
that's okay. But my question is, can we apply L'Hopital's rule here?
yes.
So does it satisfy the condition of L'Hopital's rule?
Yes, 0 by 0.
So it is 0 by 0 form, that is indeterminate form. That is okay. That is the first point. Now we have to come to the second point. So f dash x is 1 and g dash x is 1 plus cos x. Now does this limit exist?
Yes.
Yeah, this limit also exists, because 1 plus cos x will tending, as x tending to 0, it will go to 2. So it will give us half. So yeah, if x tending to 0, then we can apply L'Hopital's rule.
So actually, I am facing some problem in limit when the form of limit is 1 to the power infinity form. Then I am facing some problem to solve the limit. Can you sir just see?
Can you give me an example?
Example, yes, I can give you one example.
Okay.
Sir, for this same problem, can you take the second one, like the second option?
Second option means sin square x by 1 minus cos 2x, right?
Correct.
Yeah. So can you tell me what happens there? I just write it. Sin square x by 1
minus cos 2x.
1 minus cos 2x. Okay.
Correct.
Minus cos 2x. And limit extending to 0, right?
0, right.
Okay.
So here also we can apply the rule.
So first we have to check whether it is in indeterminate form, right? So it is in, is it in 0 by 0 form?
Yes.
Yeah, because this is x extended to 0, this is 0, and this is 1. So 1 minus 1 is 0. So it is in this form. So first condition satisfied, right?
Right.
Now what happened about the second condition?
Second condition, like your f prime x also exists, and g prime x also exists.
Okay, so what will be f prime x? Sin x?
Sin 2x.
So let me write it in this form. 2 sin x also. Yeah. And g prime x will be?
Is 2 sin 2x.
2 sin 2x.
2x.
Okay. Now what happened with this limit? So this limit will be same as
0.
2 sin x cos x by
Sin
2
2x.
sin 2x.
Yeah.
Now, what is this? This is also sin 2x, right? The numerator.
Correct.
So x tending to 0, sin 2x by 2 sin 2x. So this will cancel out. So it will give us half, right?
Correct. But now here, sir, the question is, say
Hmm.
for example, if I go to the g prime x, which is 2 sin 2x, okay.
Hmm.
Now, so that means g prime 0 is essentially 0.
That is okay. That's not the
Uh,
problem.
okay.
See here, what I am saying here, we have to calculate this limit of this one, limit of extending to a f dash by g dash x. Now, does
Correct.
this limit exist? Here only I have checked limit extended to infinity z dash x does exist because the numerator was only 1. So if this limit does not exist, the limit of denominator does not exist, then the whole limit does not exist. Okay.
Hmm. Hmm.
So
Okay.
basically our point was to checking this limit exists or not. Limit of extending to a f dash x g dash x. This limit exists or not? Does exist
Okay.
or not? Okay. In this case, this limit exists.
Okay. If this exists, then we no need to go and check like whether g prime x is 0 or not, right?
In that case, I checked that because in that case f dash x was 1. So it basically independent of x. So
Yes,
if
yes.
the limit of the denominator exists, then the whole limit exists. Because this is
Okay.
constant, right? It does not depend on x. That's why I checked there. So our
Okay.
intention was to check this limit exists or not.
Okay.
Okay.
Perfect. Perfect.
So in
Okay.
this case, this limit exists. So we can apply L'Hopital's rule here.
Okay.
Okay.
Thank you.
Excuse me, sir.
Okay.
Yeah. Thank you.
Can
Yeah.
I say the
Uh,
answer, sir?
one question.
One by one, one by one. I am not hearing. Yeah.
Next question, sir.
One by infinity form is limit x tends to 2. So can you write
Limit. Uh,
limit x tends to 2,
hmm.
5x minus 9
5x minus 9.
whole to the power
Okay.
whole
Whole to the power. Okay. Whole to the power.
1 by x minus 2.
Okay. So what is the problem here?
Actually, this is 1 by infinity form. So
This is not one by infinity form. This is one power infinity form, right?
sorry, 1 to the power infinity form. So this
Uh,
1 to the power infinity form, I have facing some problem to solve this equation. How to go about it?
okay. So one better way to check it, when there is some power, we can take, suppose this limit exists and I am taking it as y. Okay. So this function, suppose I am not this limit exactly. I am taking y equal to 5x minus 9 power 1 by x minus 2. Okay. So if I take log on both sides, what log will do? Log will take this power in front, right? So I am getting this function. Our log y is this function. Okay.
Yeah.
Now you can get a function like f by g form, right?
Okay.
So now
But
it is then after calculating the limit of this function, we will again convert it to e power something, that, okay, and taking the anti-log basically. Okay. So
okay,
now the function we got here is log 5x minus 9 by x minus 2. Now is it in 0 by 0 form?
it is in 0 by 0 form.
So it is in indeterminate form, this form. Now you can apply L'Hopital's rule here, because you can check basically what is my f dash x here.
5 by 5x minus 9.
5 by 5x minus 9, and what is my g dash x here? It is 1, right? Is it correct?
Yeah.
Yes, sir.
So what will be the limit now? Can we calculate the limit now?
Yes.
So limit
But
of x tending to, my x is tending to 2, right? So this is 5 by 5x minus 9. This limit is basically 5, right?
5.
So when x tending to 2, our this function, so log y is tending to 5. So our original function was y, right? So y will tend to, if I take
E to the
antilog,
power
e power 5. Is it okay?
okay, that
So
means
whenever you see some functions like this, fx power gx, it's always better to take log of that and then calculate the limit, and then again taking antilog to get the actual limit. Okay, is it clear?
yeah, yeah. 1 to the power infinity form, it is better to take this means
Yeah. So you have to take the log of that function, then calculate the limit. I mean, it will become easier. Okay, then calculate the limit and then again taking the antilog to get the actual limit. Okay.
okay.
How did you get ln
One
y
more.
tend 10 to 5?
Uh-huh.
Ln y tended to 5.
Okay. So
Like, was it equal to 5? Was it given?
which one are you talking about? This one, right?
Ln y tends to 5.
Uh, can you repeat that? I am not getting you properly.
Ln of y tends to 5.
Because see, my what I have calculated here. So till this point, you have understood log of y is log 5x minus 9 by x minus 2. That you understood?
Uh,
Okay, so
yes,
let
sir.
me do it from the beginning.
No,
So
sir.
I have to calculate the limit extending to 2, 5x minus 9 power 1 by x minus 2. Okay, so I am taking my y to be this function.
Yes.
Okay, so I have to calculate limit of extending to 2 y. This I have to calculate, and my y is this function. Now I am taking log on both sides, so the power will come in front and I will get this function. So
Yes,
this is
sir.
nothing but log of 5x minus 9 by x minus 2. So now I have to calculate this limit. So limit of extending to 2 log of y is equal to limit of extending to 2 log of 5x minus 9 by x minus 2. Now it is in 0 by 0 form, right?
Yes,
Because
sir.
this will give me 1, and so log 1 will tend to 0, and this will give me 0. So it is in 0 by 0 form. Now what is my f dash x? F dash x will be 5 by 5x minus 9, and g dash x is 1, right? So I can
Yeah.
write this thing as limit extending to 2 5 by 5x minus 9, and this limit exists, so I just put the value there, and this will give me 5x minus 9, so 10 5. Okay, so as x tending to 2, my log y, this is basically 5. Okay, so that's what I have written as x tending to 2 log y tends to 5. Is it okay?
Yes,
I have
sir.
calculated this limit. Okay, so if log y tends to 5, then that means y is tending to e power 5. I am taking just anti-log of it. Okay.
Got it.
Okay. So our function, this is our function y, which we have started with. So our function will tend to e power 5. Is it clear?
Yes, sir.
Yeah.
So,
Okay.
for the L hospital rule,
Hmm.
first,
Actually, the pronunciation is L'Hopital's rule. Okay, not L hospital rule. Okay. Go.
L'Hopital, in
Uh,
this L'Hopital rule, first
hmm.
we try to find the derivative of numerator and denominator. Okay.
Exactly.
Once we find this, then
Hmm.
we can is it necessary to go for another differentiation, or if I able to see some application of standard limit I can put there, so I can put that standard limit and find out the value. Is it okay?
Exactly, you can find out the value. I mean, whenever you are overcome this 0 by 0 form, if you can apply some property standard limits, then you can calculate it, then it's okay, you are done. But
No.
the problem is when you
Time.
are not able to apply those things and it is in indeterminate form, then you have to go differentiate again.
Yeah.
Okay.
After state of differentiation, if the form is again 0 by 0, from the earlier one, it gets simplified. Now, even though the form is 0 by 0, I can see I can apply some standard limit by.
You can do that. You can do that. There is nothing wrong with that. You can do that. I mean, L'Hopital's rule is basically one of the way to calculate the limit. Okay. But if you can apply that standard limit in any steps, you can apply that. Okay. But if you are not in a position to apply those standard limit, you have to go for the L'Hopital's rule again. Okay.
And if you have some time at the end of this lecture, you just want to know the derivative.
Your voice is breaking. Rajiv is talking, right?
No, sir.
Who is talking? Your voice is breaking.
Sir, can we take that activity question 2.2?
Or
Question number
actually, I
6.
have one more down, like 2.3, the next one, 7th. Discuss it.
Okay, so let's finish this 2.3 question 7, then I will come back. This one, right? Fx plus y equal to fx. So f0. So can you tell me so that I can write it here?
Yes, sir. F of x plus y
Hmm.
equal to f of x into f of y
Okay.
for all x comma y belong to R.
Okay.
F of 9 is equal to 6.
Okay.
F dash 0 equal to 4.
Okay.
Then f dash 9 is like find f
Okay.
dash 9.
So what is the definition of derivative at some point? So suppose I am trying to find f dash a, then what is the definition? The definition is
Limit h
h
tends to
tending to 0.
f plus h minus f of a upon h.
Yeah, so if this limit exists, then we say that the function is differentiable and the derivative at that point is nothing but f dash a, right? So this was the definition. So here I have to calculate f dash 9. Okay. So it will be f9 plus h minus f9 by h. Now the function is given as fx plus y equal to fx into fy, right? So I can apply this here. So it will give me f9 into fh minus f9 by h. Okay. So I can take f9 common in the numerator. So it will give us this by h. Till that this is okay. Till this point is this okay?
Yeah. Yes,
Yes.
sir.
Okay. So what is my f9? F9 is basically a constant, is given as 6. So this is 6 fh minus 1 by h. Now what is f dash 0? Let us calculate that. F dash 0 is nothing but limit h tending to 0, f of 0 plus h minus f0 by h, right? Is it okay?
Yes, sir.
So it will give us limit h tending to 0, f0 into fh minus 1. So I can take this common and this h. Is it okay?
So
Huh. So what? Yeah. Yeah. Someone is saying something.
You continue, sir.
Okay. So this is. So can you solve it now? I mean, it's now clear, right? We know the value of f dash 0. We know this value. So you have to just put it here, right?
dash 0 value is given to be 4 and f dash 9. So for fetch minus fetch. So sir,
Hmm.
what are where I have to substitute the
You have to just
factors?
substitute this f0. These things are constant, right? So
Yes.
f0 can be this. So f dash 0, you know, f dash 0 is 4. That is given,
Yes.
right? And this is nothing but 6 into limit h tending to 0 fh minus 1 by h, right? So I just calculated this value.
So f limit h tends to 0, f of h minus h, it should be substituted. So 6 into
Exactly. Exactly. Yeah.
one
So it's
more.
okay, right?
Yes, sir. Got it.
Yeah.
Sir, and one more. It's actually 4. That's 2.4. Question 6, question 7.
Activity question 2.4.
Sir, 2.2, sir, activity question 2.2,
Okay, 2.2. Which one?
question number 6.
Question number 6.
Yes. So,
Huh.
yeah, sir, the doubt is like, say, for example, whenever there is an inverse function,
Hmm.
okay, if the function is differentiable, then the
Okay.
inverse function is also differentiable, like, because inverse function is the reflection of the function around y equal to x, right?
Uh, okay. But
Then,
is it always true that if a function is differentiable, then its inverse function is also differentiable?
no, no, like, the question is like,
Hmm.
what we understood from maths 1, okay,
Hmm. Hmm.
inverse of a function is the reflection of that function around y equal to x. Okay. If
Okay.
that statement is correct, then
Hmm.
if the function itself is differentiable, then when we are taking the inverse of it, we are not changing the characteristics of that function. So then it
Uh,
has to be differentiable.
okay. So let me give you an example, I think.
Yeah, correct. That should be good, better.
Okay. So any other doubt before I come to there?
Sir,
No, no.
Yeah. Yeah. Tell me.
sir, I
Sir?
just had one conceptual doubt actually. So if
Hmm.
suppose we are talking about arbitrary functions f and g, fx and gx, okay, we're trying
Hmm.
to, I mean, the function actually it is a rational function like fx by gx, and we are trying to
Hmm.
evaluate the limit of the function at x tends to a, okay,
Hmm.
x tends to a fx by gx. This is the function we are
Okay.
talking about. So
Hmm.
after using the L'Hopital rule, I mean, after
Hmm.
calculating the f dash x, g dash x, okay, if we
Hmm.
can't evaluate the limit at x tends to a, that means
Hmm.
can we conclude that the function is not continuous at x equal to a?
If you cannot calculate the limit,
After applying the L'Hopital's rule as well.
or if that does not exist, limit does not
Yeah,
exist.
yes. I mean, there were two conditions, na?
Hmm.
For L'Hopital's rule to be applied on a particular function, it means, say
Hmm.
for example, it has to be in the indeterminate form, like 0 by 0 or infinity by infinity.
Hmm.
And then in the second condition, it was like that f dash by f dash and g dash should also be, you know, computable at x equal at as x tends to a.
Not
I mean, after doing all those things
computable.
also, I mean,
Not computable. I am saying that if this limit exists or not, you have to check that, right?
yeah, that's what I'm saying.
Suppose
If
you are saying, suppose this limit does not exist,
does not exist,
right?
yeah,
Suppose this limit does not exist,
does not exist.
then you conclude that this limit
Uh,
also does not exist, right?
that means it is not continuous at x equal to a.
It is mean which one?
I mean, this function fx by gx. This
So our
function
function is hx, which is fx
hx,
by
yeah,
g.
yes,
So you are saying that hx is not continuous at a.
yes.
Yeah, obviously, because limit does not
Okay,
exist. So it is not
okay.
continuous at a. Because the main condition is not continuous at x equal to a. Because to be continuous of a continuity of a function, this limit has to exist at first,
Yeah,
and then it has to be the exact value h of a. If
yes,
this
HF.
happens, then only we say that function is continuous. Now you are
Yes,
saying that this limit does not exist, then obviously this function is not continuous.
okay. Thank you, sir.
Clear?
Yes.
Okay. So yeah, so can you say me the definition of inverse function?
So that x and y get interchanged, like
That is not a definition. That was a vague statement which was given to understand that thing, the visualize inverse function.
correct.
Do you remember what was the definition of inverse function?
Whose composites functions are the same, like f of g is
Yeah,
equals to g.
Oh yes,
yeah.
right.
And it has to be equal to identity function.
Identity.
Okay, that means x, nothing but x. Okay, so this was then we call f and g are inverses to each other.
Right.
G is inverse of f and f is inverse of g.
Mhm.
Okay. Now, suppose I am giving my function fx. What is the inverse of x square? Can you tell me what is the inverse of x square? Can you calculate it?
Root of
What
x.
is the inverse of x square?
Root of x.
X.
Square root of
Yeah. So you are saying that this is square root of x, right? Why? Because f compo. What is f composed g of x?
Square root of x whole square. So x. That will be square root of x whole square.
1 minute, 1 minute. Give me a minute, okay? There is some need. Can you hear me? Hello?
Yes, sir.
Yes, sir.
Okay, let me share my screen. Okay. Yeah, so what we are doing, what is f composite G? So it is f of root x and this root x square. So it will be x square x, right?
Yes.
And what is G compose x?
Root of x square.
So G of is root of x square. What will be that?
X.
Yes.
Is it always x?
Oh, plus minus x.
That's my question. I mean, when it is plus x or when it is minus x, or is it always plus x? This you have done in math 1, right?
When x is greater than 0, then
Huh?
when x is greater than 0, then plus.
Sir, it will be plus x because x square is a positive number.
Hmm.
X square inside the square root, like x square
Huh?
is a positive number. So when it will come outside, it will be like plus.
Why? I mean, 4 is positive number, but I mean 4 power half. Root 4 is particular number. So 4 power half. Suppose I am taking this. Is it always a positive number? I mean square root of 4. So this is true number, right? Plus minus 2 this can be. Right?
We
Yeah.
check, when the plus x and when it will be minus x, we have to check both the conditions, and we will find g of x according, and we will see conditions of x and g of x.
Can you repeat?
What I am saying is root under x square is but we have to say considering the plus x, and then again considering the minus x, for which this x is extended to function of x.
So you are saying that you have to check it for its domain. Hello.
Sorry?
You are saying that we have to check it for its domain.
But sir, here it has to be x because like your since it is the inverse function fog of x and g of
No, I
x.
am not saying it is an inverse function. I am checking whether it is an inverse function or not.
Okay, you are checking.
So my question is it an inverse function of x square? That's my question.
We need to check that. Suppose I don't know now root under x square is equal to plus x or minus x. Suppose
Okay.
it is then again we check the minus x. One of the is satisfied. If satisfied for plus x, then we can say g of x.
Okay, so before going further, can you say me this domain of G and range of G? What is domain of G and what is range of G? Here, I mean G is equal to root x.
Yeah, like
What is
so.
domain of? Yeah.
Yeah, domain of G is any positive real number.
Domain of G is any positive real number, exactly. Okay.
Right.
So domain of G is any real number such that x is positive. So R
Correct.
plus. Yeah. And what is range of G?
If x is positive, that means that is also a positive y axis actually.
So whenever I am considering this root x, this root symbol denote is always a positive number, right?
Positive number, right? Yes.
So it is already positive. So there is a difference between this and this, right? So this is exactly a positive number. I mean, you are using root 2, root 3. So these are all numbers. So there are symbols for minus root 2. These are negative numbers. But when I am saying 4 power half, this can be plus 2 or minus 2. But when I am saying root 4 is always a positive number. Okay?
Correct.
So here it is nothing but x. Okay?
Yes.
Yeah. So that's what my point is. I mean, because here we are always taking the domain of G as positive number. So what we are getting outside that is also a positive thing. So this x is belongs to that positive number. So in this case, we are getting f compose G as identity function, right? So these are inverses of each other. Okay. Now, f is differentiable. Is f differentiable?
Yes.
Differentiable at 0.
Yes. Or 1 by 2 root
F
x.
is x square. Okay. And my gx is root x.
Root x.
So is f differentiable at 0 and is g differentiable at 0?
By 2 root x.
Hmm.
But yeah, 1 by 2 root x, and that is x equal to 0. That means it is a vertical line actually.
Which one?
At x
Definitely
equal to
differentiable at
0.
zero.
Yeah, and it is a vertical
G
line.
is not differentiable at 0.
Why? Can you say me?
I have
Vertical
to.
line. It's a vertical line.
So that I'm just trying to recollect the lecture. The lecture takes g to x to the power of 1 by 3 as an example, right? To show that y is not differentiable at 0.
Not
Right? This is x to the power of 1 by 2,
because
which is
the
comes to the
slope
same.
is infinite.
Yeah. Can you repeat? You are saying that slope is
Vertical.
G is not
basically
differentiable
the
at 0.
tangent at
Slope is infinite.
yeah. Yeah. So let me show you the graph of this, then it will be clear more. So if I so my function is x to the power half. So you can see this is x power half. So if I take square root of x also, this will work. Yeah. So you can see this at this position at 0, x equal to 0. The tangent looks like tangent is basically y-axis, right?
Correct.
So the slope is undefined. Slope is undefined means the derivative is undefined. That means the function is not differentiable at that point. But for x square, it is differentiable everywhere because it is a polynomial function, right?
Okay.
So there is some issue with differentiability. I mean, it may not exist at every point.
Mm-hmm.
Okay? So that's why the
Okay.
question. I mean, if f is differentiable everyone, that does not imply that its inverse is also differentiable everywhere. Okay.
Okay.
Okay. So is it clear, right?
Yes. So it
Very
should
clear, sir.
support.
Thank you.
Yeah.
Yeah. Great explanation, sir.
Sir, can you
Question
please
activity
activity
2.1, question number
questions
8.
is related to box and ceiling. Confused in it. 2.2, question 3 activity. 2.2 question.
2.2 question 3. Okay. Floor and sleep.
Yeah.
Okay. And someone is asking something else. I will explain this. And
Explain
someone is
this
asking.
later on. I'll ask.
Okay. So floor and box one. So fx is. Can you tell me which one is floor and which
Yes.
one is box?
F of x is equal to floor of x if x greater than equal to 0. Floor of
Okay.
if x greater than
And
equal to 0.
ceiling of x if x less
X
than
less
0, right?
yes.
Okay. So can you tell me the definition of floor and ceiling? What is floor of x?
In floor of x, we take the integer lesser than the value. Ceiling of the x, we take the integer that is greater than the value.
So it is greatest integer less than or equal x, right? So basically, I am taking, if I am taking this, so it is a. So if a is less than equal to x and a is an integer, right?
Yes.
The least integer, I mean this, and strictly less than a plus 1. So in between these two integer, I am taking the integer which is less than that, right? So floor of 2.5 is nothing but 2. Is it okay? The definition is clear for floor function.
Yes.
And for ceiling function, it will be 3, right?
Yes, sir.
So it is basically for ceiling function, it is least integer greater than or equal x. Okay, so these are two definitions. Okay, now what are the options there? in the question?
So differentiable at x is equal to 0.
Okay.
So
So
differentiable
let me see the option. Differentiable at x equal to 0, differentiable at x equal to 1, differentiable at x equal to -1, and differentiable at x equal to 1.5. Okay, so there are 4 points: 0, 1, -1, and 1.5. We have to check differentiability at these 4 points. 1.5, these 4 points. Okay. Okay, so we'll go by definition. So at first, for 0, for x equal to 0, can you say what is the value of this function at x equal to 0?
0. 0, sir.
Yeah, exactly. So this is floor of x when x greater than equal to 0, and ceiling of x when x is less than 0. So f of 0 is nothing but 0 here. Okay, so is f continuous at 0?
Yes, sir.
Why?
Sir, because like I did it by assumption. If I take
What is this limit? What is
uh,
this limit?
x tends to 0, it will be 0.
0 from positive side. Okay,
Yes.
so from positive side means for 0 to
0
1, till 0 to 0 to 1, open 1, the function value is 0, right? Fx equal to 0 when x belongs to 0 to 1, right? And from negative side, what will be the value? So it is 0, you are right. And when x belongs to say -1, sorry, -1 to 0, what will be the value?
It will be again 0, sir.
Yeah, because we are taking ceiling function of that, right? So
Yes.
limit of extending to 0 minus, that is also 0. So limit exists at 0, and it is nothing but 0, which is same as f0, right? So f is continuous. Okay. Okay, so that's how we check. Now for differentiability, what we have to check? Limit h tends to 0. This, right? This limit exists or not. So for 0 plus, from the positive thing, h tending to 0 plus, it is h minus f0. F0 is nothing but 0, so I am just removing it, and this. Okay, so what is the value of fh?
F of h.
H is positive side of 0. Okay, so this suppose this is my 0, h is somewhere in between this, neighborhood of this, so in the right side, right neighborhood maybe.
Sir,
So what
because
will
we
be the value of fh?
0 plus, that's why.
Yeah. So h is in the neighborhood, which is right side of 0, I mean this portion. So it is nothing but 0, right? Is it clear
Yeah,
why this fh is 0?
f of h is 0. Like if I substitute f of 0, then it will give me 0. That's why.
No, 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 no. This is not substitution. Okay, so let me explain in this way. What we are doing here, we have to take this limit. So this is my 0, here is my 1, here is my -1. Okay, so when h tending to 0 plus, that means h is approaching to 0 from the positive side of 0, right?
Yes, sir.
H tending to 0 means 0 plus means we are approaching to 0 from the positive side, right? From the right hand side of 0, right? And h tending to 0 minus means we are approaching 0 from the left hand side. Is it clear?
Yes, sir.
This is h tending to 0 plus, and this is h tending to 0 minus. So in this neighborhood, in this positive side of 0, the value of the function is 0, right? So
Yes.
this will give us 0. Is it okay?
So sir, f of 0 is 0. 0.
Not that's why it's 0. I mean, suppose my age is here. This is my age. Okay. Suppose this is my age, some number. Okay. And that f of age, then f is 0, right? Because through this interval from close 0 to open 1, in this interval, the value of the function is 0, right?
Sir.
So whatever value I am taking here, everything is 0, right? If we approach 0 from the right hand side, all the functional values are 0. Is it clear? So let me explain this. So this is the right side of 0, and I am approaching towards this right side, right?
Hmm.
Is it clear?
Yes, sir.
So whatever the value we are taking in the right side, this is 0. Everything is 0 here, the functional value, right? So this limit will be 0. Is it clear?
Hmm.
Now if we take from the left side, the same thing, 0 plus h minus f of 0 by h. What will be the value? Again, this is extending to 0, fh by h, because f0 is 0. And now we are approaching 0 from the left side, right? Suppose there is my minus 1, and I am approaching from the left side, h tending to 0 minus. So what are the values here? Values of the function here? Again, this is 0, right? So it is again 0. So this limit exists. Limit. So limit h tending to 0, f of 0 plus h minus f0 by h. This limit exists. So the function is differentiable at 0, because this is the definition of differentiability, right? If this limit exists, then we say that f is differentiable at 0. Is it clear?
Yes, sir.
But
If we want
in
to
lim-
check differentiability at the point 3, then we should take limit h tends to 3 plus and 3 minus.
Exactly. Exactly. So
but
suppose I am doing it for, so there is a
f of
question x equal to 1, right?
Yes.
So let me check this, then it will be more clear, I think. So this is h tending to 0 plus f of 1 plus h minus f of 1 by h. So these two limit we have to check for differentiability at f equal to x equal to 1, right? So
Sir, we
1 plus h is,
uh,
yeah,
con- as we did for the 0, we checked the continuity. So here we didn't check the continuity for 1.
you can check it. I mean, I was checking directly for explanation. Yeah, you can check the continuity. So is this function continuous at 1?
So
No, sir.
1.
No, right?
No.
Why?
Yeah, because 1 minus will tend to, no, sir. Yeah. 1 minus will tend to 0 and 1 plus will tend to 1. Sorry, 1.
Exactly. So if I am approaching from the left side of 1, the value will be 0. If I approaching from the right side, the value will be 1. So this limit does not exist, so function is not continuous. And you know that for differentiability, if a function has to be differentiable, the function must have to be continuous. If it is not continuous, then it cannot be differentiable, right?
Yes, sir.
So f cannot be differentiable at x equal to 1. Okay.
Yes,
So
sir.
if I use the definition directly without checking the continuity, I mean, if you check continuity beforehand and it is not continuous, then obviously it is not differentiable. That is okay. We got the answer. But to explain it, I am checking the definition of differentiability directly. So what I get here, the same thing, same kind of explanation. This is 1 plus h. And what is f of 1? F of 1 is 1, right? This, right?
That is floor of x, right, sir?
Yeah. So for x is positive here, so it is floor of x. So f of 1 is 1, right? So if I am approaching from the right hand side, what will be this value? So there is somewhere my 1 plus h, and our h is coming from this side. So f of 1 plus h is always 1, right?
Yes, sir.
So it is 1 minus 1, that will give me 0. But if I am taking this limit from the negative side, this is f of 1 plus h minus 1 by h. Now f of 1 plus h, I am approaching from the left side. And from the left side, this is nothing but 0. f of 1 plus h is 0, right?
So why you are writing 1 plus h? Why don't you write 1 minus h?
Because I am taking h to be 0 plus or 0 minus. That's generally we in the definition of this function, right? So for checking differentiability at some point, I am checking this thing, this limit, right?
Okay.
The definition of differentiability, right? If this exists,
Yes.
this limit exists, then it is differentiable.
Mhm.
Now, for checking whether this limit exists or not,
Sir, in
we have to
this,
check.
can I ask a question?
Yeah, sure.
So in this, the 0 by 0 form is neglected. In this, if it's a 0 by 0, we don't like that doesn't matter.
Where?
Like for example, in the previous equation that you wrote also, limit h tends to 0. It was 0 on the numerator as well as the denominator.
There is some problem here. See, I have written that limit h tend to 0 minus, suppose fh minus fh by h, right? This one I have written, okay?
Okay.
So you are saying, so I am saying here, suppose my h is some number which is on the left hand side of 0, okay? Suppose I am taking h1 for defined notation. I am taking h1 which is at the left hand side of 0, okay? So this is my h1 by h1. Now this h1 is not 0, right?
Got it.
h1 in the neighborhood of 0, but h1 is not exactly 0, right? So this is not 0, but fh1 is 0, right?
Yeah.
So this thing is basically 0 by h1, and I am getting 0. Now I am taking another number h2 which is nearer to 0. You can see the picture, right?
Yeah.
Here my h1, I am taking h2. Now again this is f of h2 by h2. So this is again 0, right?
Yes.
Because of h2 is 0, h2 is non-zero, right?
Yes. Got
So
it.
as
Thank
we
you,
are
sir.
approaching to 0, every number like this, f of hn by hn, I am getting a sequence like this, right? This is a sequence.
Yes.
And in this sequence, every number is 0, right? It is a constant sequence where every number is 0.
Yes.
So as n tends to infinity, I am getting the sequences tending to 0, because sequence converges to 0, because every number is 0 there.
Yes.
That's how we got this limit to be 0. That is the concept of limits that has discussed in week 1, right? By explaining the sequence first, then we come to the function, right? So here, functional value is always 0, whether h is non-zero or not. In the neighborhood of 0, this functional value is always 0, right?
Yes.
So our limit is obviously tending to 0. Is it clear? Here it is not 0 by 0 form. That is not entirely true. Okay?
Yeah, thank you, sir.
Yeah.
Sir, in this I didn't understood that above limit h tends to 0 minus. We did this 0 minus f
This
of
one.
1 plus h minus 1 upon h. Limit h
This
tends.
one, right? Okay.
After this.
So I am saying, suppose this is my 1, okay? And 1, if I h tending to 0 plus 1 plus h means this is in right hand side of 1, right? This is 1 plus h.
Yes.
H tending to 0 plus means h is greater than 0, okay? And h tending to 0 minus means this h we are taking from the left hand side of 0. So 1 plus h, when h is positive, that gives us the right hand side of 1. and 1 plus h tending to 0 minus means this is left hand side of 1. Okay, is it clear?
Yes, sir.
So 1 plus h if h is 0 minus. So when I am at the right side of 1, the functional value will be 1,
1.
right?
Yes.
So this is 1 minus
Yes.
1, the numerator is always 0.
Yes, sir.
Okay, so the if we are approaching towards 0, this value is always 0, right? So the limit is 0. Now if I am approaching from the left hand side of 1, now what is f of 1 plus h?
Sir, it will be 0.
So it is so the 0 minus 1, 0 minus 1 by h, right? So this is 0, right? So this limit does not exist. I mean h tending to 0, this is nothing but limit 1 by h minus 1 by h tending to 0. So this limit does not exist, right?
Yes, sir. Because H diverges, right?
Because 1 by h. So h, if we are going, if we are taking h is approaching to 0, then 1 by h approaching towards infinity, right?
Yes.
So it is
Yes.
basically undefined. So this limit h tending to 0 minus this limit is undefined, and this limit although exists and it is 0. So limit h tending to 0 does not exist. So this function is not differentiable. Is it clear?
Yes, sir. Got it.
So,
Understood.
from both sides of 1, we have considered this greatest integer function since x is greater than 0, equal to 0. That is why, right?
Yeah, exactly. So when I am considering the differentiability at x equal to 1, so it is obviously x is greater than equal to 0. So we are considering only the first piece of this function, this floor function, this function, right?
Yeah. Okay.
Yeah.
Excuse me, sir.
So is it clear, no? This differentiability of this function?
Yes, sir.
Okay.
Activity 2.1, question number 8. Can you please?
Activity 2.1, question number 8.
Question number 8.
Okay.
Last one. Yes, this one.
It is continuous as 0. Yeah, I think it has discussed in discourse many times, right?
Sir, it has been discussed in the activity solve with instructor session.
That session also
Okay,
it has been
okay.
discussed. So okay, someone
Okay.
can tell me how to solve it.
Yes, sir.
So my function is fx 1 by e power 1 by x, right?
Yeah.
This was the function, right?
Yes.
Yes.
And for x equal to 0, it's 0. Okay. So this is x not equal to 0 and this is x equal to 0. Now we have to check is f is continuous or not. F is continuous at x equal to 0. Okay. So yeah, what is the right hand limit of 0? Can you tell me what is the right hand limit of 0?
0.
0.
So these two things we have to check, right? Right hand limit and left hand limit.
Left hand.
So right hand limit means we are approaching from the positive side of 0, right?
Yes, sir.
And left hand limit means we are approaching 0 from the left hand side, from the negative side of 0,
Yes, sir.
right?
Yes.
Okay. So can you tell me what will be that? What will be these two limit?
Right hand side is 0, sir.
Why?
Because this 1 by infinity, e to the power by infinity is it is approaching towards 0. So it is coming from 1 by 0 means e to the power infinity. Infinity plus 1 is infinity. 1 by infinity is 0.
Then left hand side?
Left hand side is the minus infinity e to the power.
Why?
Because we are approaching from the minus infinity towards 0.
Okay.
So
Then?
it is 1 by 1 by to the power 0. So 1 by 0 is this infinity. So 1 by infinity against 0.
So you are saying it is continuous as 0.
No, not continuous.
Why?
Left hand side and right hand side is not matching, no?
You are saying both are 0, right? No?
No.
Okay.
Sir, from the right hand limit it is 0.
From left hand limit?
From left hand limit it is 1 by this minus 1 by infinity 0. From left hand limit it is coming as half.
Why?
Because e to the power 1 by minus infinity. So it means
Minus, why they are getting minus infinity? Even 1 by minus infinity
then that means 1 by e to the power infinity.
1 by e to the power infinity. Okay. Then also it's 0, right? Whatever you are telling.
This e to the power 1 by x, this terms is 0. So 1 by 0 plus 1 is coming as 1. Or I am making a mistake, I don't know.
Okay. Anyone wants to try it? Just try it. Just try to explain. Yeah, sure.
So, sir, for x tends to 0 plus limit x tends to 0 plus f of x, it will be from the right side, that is xn greater than 0. So, 1 upon x, x tends to 0, so 1 upon x will tend to infinity. So, e raised to 1 upon x, it will also tend to infinity. 1 raised to x, 1 by x, it also tends to infinity because e to the power 1 upon x tended to infinity previous step.
Okay.
We get 1 upon 1 plus e to the power 1 by x, that is 1 upon infinity, which tends to 0. So ultimately the limit from right hand side is 0.
Okay.
So for the left hand side, x is less than 0. I mean it is less than 0. So 1 upon x, and it will be tending to minus infinity. And then e raised to 1 upon x, that is e raised to minus infinity, it tends to 0.
Okay.
So 1 plus e to the power 1 upon x, it will tend to 1, like 1 plus 0, as e raised to minus infinity was 0. So it tends to 1. Then 1 upon 1 upon n, it is 1 upon 1, which tends to 1. So limit does not exist, as the left limit we calculated it as 1 and the right limit is calculated as 0.
Okay. So yeah. So do you understand what she is telling? Hello.
Half of what she said was inaudible.
Okay. So suppose I am approaching 0 from the right hand side. Okay. So what we get here? If I am approaching 0 from the right hand side, that means I am taking some numbers here which are in between, in the neighborhood of 0, and which is positive, right? X tended to 0 plus, that means this x is positive, right?
Yes.
Yeah. So, and I am approaching 0, so this 1 by x is tending to infinity, as this is positive. So e power 1 by x is also tends to infinity, and it so this denominator is tending to infinity, and 1 by that, so that will be, so this limit will be 0. So this is clear, right?
Yeah.
Yeah. Now when I am approaching from the left hand side, then what happens? Then my x is basically negative, right? Is it clear?
Yes, sir.
Yeah. So when I am approaching from the left hand side, my x is negative. So what about this e power 1 by x? This x is negative now, right? So suppose I am taking my x equal to minus h. Okay. So what I can write it? I can write it 1 e power minus 1 by h, right?
Yes, yes, yes.
So x is negative means this h is positive now. Okay.
Yeah.
Yeah. So I can convert this limit x tend to 0 minus fx. This I can transform into h tending to 0 plus f of x equal to minus h, right?
Yes, sir.
These two are same.
Yes.
Okay. Yeah. So I am saying 0 plus f of minus h is 1 by e power minus 1 by h plus 1,
Yes, sir.
right?
Yes, sir.
Okay. So this I can write it as 0 plus 1 by, now this is 1 by e power h, right?
Yes,
Plus
sir.
1. So
Yes, sir.
I am getting e power 1 by h plus this thing, right? So basically I have to calculate limit h tending to 0 plus e power 1 by h by
So this is
1
1,
plus e
right?
power 1 by h. Okay.
Yes, sir.
So as you can see, as now my h is positive, right?
Yes, sir.
Yeah. So what is this limit? Can you
1.
tell me what is this limit?
1.
Yeah, 1. Why? Why?
So this I put this 1 by 1 by uh, 1 by e to
So
the power
basically,
h plus 1. In that step only I can see that.
basically here you can see it itself, right?
Yeah.
Yeah,
Yes.
yeah, yeah. So
Okay.
this
So
limit is nothing
clear
but,
now. It is clear now. So left hand limit is not equal to the right hand limit. That's why it's not continuous and x
exactly,
equal to 0.
exactly.
Okay.
So
Okay.
the
Thank you,
point
sir.
is basically here I am having a function e power 1 by x. Now it
Yes, sir.
depends on whether x is positive or negative,
Or negative.
right?
Yes, sir. Yes,
So
sir.
that is the main point of this problem. When x
Sir,
is positive, then this is clear. 1 by x is going to infinity, so the denominator is going to infinity, so the limit is 0. But when x is negative, then what happens? Then
yes, sir.
actually x is negative means x is some minus of x. So it is not exactly e power 1 by x. It is basically 1 by e power 1 by h, where h is positive,
Yes, sir.
right? So that's how we
Yeah.
calculate this limit, and these two limits are different now. So f is not continuous at 0. Is it clear?
Yes, yes, sir. Yes.
Yeah.
Thank you, sir.
Yeah. Okay.
Sir, I had just
Yeah.
one small doubt, like not in this, but it is related to the same activity, question 4. I mean, I don't want the entire explanation. Only the partial correct, like f is continuous. They have given if a equal to b. It is question 4.
Question 4. Okay. Same
2.2.
activity.
Yes, sir.
Yeah. Okay.
So, sir, in that question, they have given like f is continuous if a equal to b. Like I understood a equal to b equal to 0, it is continuous. But that I did for 1 also. So, sir, I wanted to ask that here we have to check the continuity at point 1 itself, right? And not anywhere else.
Yeah. So this kind of question, see, when x is greater than equal to 1, the function is ax, right?
Yes, sir.
So ax is always continuous. I mean, when x is greater than equal to 1, the function is always continuous,
Yes,
because
sir.
ax is a linear function. So linear function is continuous. You can see that. And when x is strictly less than 1, then also the function is continuous, because bx square, this is a quadratic function. So it is always continuous, right? So only
Yes.
problem arises when x is equal to 1. In the both
Yes.
pieces, there are two pieces. This is piecewise function. So in the both piece, each piece is continuous. So for x strictly greater than 1, the function is continuous. X is strictly less than 1, the function is continuous. So we don't have to check anything there. So only problem arises when x is equal to 1. So we have to check only for that point, x is equal to 1. Is it clear?
Oh, yes, sir. So I just took an example, a equal to b 0, that I solved it, and I just took a equal to b equal to 4. So 4x and 4x square. So it will be from the x tends to 1 plus and 1 minus. The limit x tends to 1 plus 4x and limit x tends to 1 minus 4x square. I will substitute 1, 1, and ultimately both the answers will come as 4. So it is continuous, right?
Yeah, so if you take a and b to be 4 here, so this function is continuous. Yeah, at x equal to 1 it is continuous because the right hand limit will be 4 and left hand limit is also 1 and 4. Yeah, correct.
So, sir, whatever will be the value of A and B, I have to check the continuity at the point A.
Yeah.
Yeah.
So you can basically directly check it. I mean, you don't have to take a particular example here. So the function you have given is ax and bx square, right?
Yes, sir. For x
This is
greater
the
than.
yeah. So limit extending to 1 plus when I am from the right hand side of 1, this side. The function is ax, right?
Yes, sir.
For x greater than 1, the function is ax, right?
Yes, sir.
So what will be the limit of this function? This is nothing but a, right?
A. And
Okay.
ax also A. Okay, okay. Well, limit x tends to 1.
So this is limit of extending to 1 minus this is bx square, and so this is also b,
And then
right? So now limit has if limit has to exist, then these two has to be equal, right?
yes, sir.
1 minus, sorry, 1 minus these two has to be equal and this has to equal to f of 1 for continuity. This is for limit has to exist and this is for continuity. Okay.
Yes,
So
sir.
this limit you calculated as a, this is calculated as b, and what is f of 1? F of 1 is also a. So yeah, a equal to b equal to a. This is obviously true. So when a equal to b, then only the function is continuous. No other condition is required. Okay.
So I didn't, I just took a long path, like I took an example that was.
You took an example, but that is not necessary here. You just can calculate it directly from here. Clear, no?
Yes, sir.
Sir,
Yeah.
can you do practice assignment last question?
Week 2, right?
Yes.
Okay. Yeah. So last question means this is comprehension type question. So basically you have done 8 and 9.
Yes, sir. I just want to know
Huh.
how you calculate linear approximation.
Oh, okay. Okay. So suppose I have a function fx. So linear approximation is nothing but f dash x, linear approximation at some point a. Okay. So linear approximation at some x equal to a. So this will be f dash a plus f of a. This is the linear approximation of the function at a point x equal to a. So this is nothing but the tangent of the function at that point. Okay. That is basically the linear approximation. Is it clear?
Yes, sir.
So here the function which is given. So at first you have to assume that function is continuous at t equal to 3. So that is given because if t is 3, I mean continuous at t is 3, then this value of n is known, right? This value of n will come, I think, as 3.
It's 3. 3.
Yeah.
Yeah.
Yeah. So our function becomes fx, sorry, ft here. Ft is t minus 2 power 3 minus 1 by t minus something like this was the function, right? T minus 2 power half. So this is for 0 to t to 3, and for greater than equal to 3 this is floor of t. So this is floor of t for t greater than equal to 3. So these are the function when this function is continuous at t equal to 3. Okay.
Yes, sir.
So now you have to calculate this linear approximation at point t equal to 1. So when t equal to 1, which part you will take as your function? This part, right?
Yes, sir.
Yeah, because t equal to 1 lies in this interval 0 to 3. So at t equal to 1, I have to take this function t minus 2 cube minus 1 by t minus 3. So as t equal to 1, so I will have to take the differentiation of this function, I mean derivative of this function. So what is f dash t? If you calculate it, I think it will be this t minus 3 minus t minus 2 whole cube minus 1 into 1. So this is nothing but this by t minus 3 whole square. So this is your f dash t. Now if you have to calculate f dash t at t equal to 1, so you put the value 1 here. So it will be this. So I think you got the idea how we have to solve it, right?
No, sir, I'm not getting the answer.
Okay. Yeah, so this f dash 1. So you have calculated f dash 1?
Yeah, no, like I couldn't get it.
Okay. So I think this is 3 into 2 minus 6 plus 2 and minus 4 by 4. So this is minus 1. So f dash 1 is minus 1. What is f of 1? F of 1 we also need. F of 1 is 1 minus 2 whole cube minus 1, 1 minus 3. So this is minus 1 minus 2 by minus 2. So this is 1. F of 1 is 1. So the linear approximation is LFT, which is f dash 1 at t equal to 1, f dash 1 t minus 1 plus f of 1, right? So f dash 1 is minus 1, t minus 1
So you're
plus 1.
taking the value of a as 1.
Yeah, because at x equal to a, this is your linear approximation, right? At x equal to a, your linear approximation is basically the tangent at that point, f dash a into x minus a plus f of a, right? So
I
here
thought
we have
you
to
have to calculate at x equals to 1. So when I
yeah,
put
that's
x
what I am doing, no? X equal to 1.
no,
I mean here x is t.
I mean t equals to 1. I mean a should
So that's what,
be something else.
what?
I thought that we have to put t equals 1 and a should be something else. Just have to find out of t equals to 1.
No, why? See here, see at first here, I mean x and t are same basically. Here my variable is t, not x. Okay. So t is
Yes,
my
sir.
variable here. At t equal to 1, we have to calculate the linear approximation. So linear approximation of some function ft. Okay. So the linear approximation at t equal to 1 is nothing but f dash 1 into t minus 1 plus f of 1, right?
Like mx plus c.
Yeah, exactly. Okay.
So I'm confused at this part. Like, shouldn't be instead of t minus 1, it should be 1 minus a and
What
plus
is
f.
a? What is a?
A is a point at which it's a point we know that value of
Okay.
a,
Leave it. Leave it.
but we
Leave it.
don't know the
Suppose
value of
I
t.
leave it. Suppose I have a function fx, and I have to calculate the linear approximation at x equal to a. Okay.
Yes, sir.
What will be the linear approximation? It is f dash a x minus a plus f a, right?
Yes, sir.
Now here my function is f of t. I mean instead of x, my variable is t. Okay. And at t equal to 1, I have to calculate the linear approximation. Okay.
Yes, sir.
Okay. Suppose t equal to a, I have to calculate first. T equal to a, I have to calculate the linear approximation. So this is just change in variable. So instead of x, I have variable t. So this does not change anything, right? This is my linear approximation at t equal to a. Is it clear?
Yes, sir.
Now at t equal to 1, we have to calculate it, right? So what is the value of my a? My a is nothing but 1 here. Okay. Is it clear?
It's 1.
I mean,
I
t equal to, instead of t equal to a, I have to calculate at t equal to 1. So what is a? A is my a is 1, right? I mean, yeah, I mean, I don't know how to explain it.
So, if it possible, you can show also on graph.
That is okay, but I think she is confused with this a and 1. I don't know why. Now you got it? Or
Yes,
should
sir.
I try something else to explain it?
You
I mean,
can
see,
try.
yeah, suppose suppose a function is given, okay? This is my some f of x, okay? So linear approximation at some point, suppose this is x equal to a. This is the point. So this point is x, sorry, a f a, right? This is the coordinate of this point,
Yes,
okay?
sir.
Okay, so the linear approximation is nothing but the tangent at this point, okay? So we call this function, this equation lf x, as the linear approximation at x equal to a. Is it clear?
Yes, sir.
Okay, now suppose I am taking the same function and this is my point x equal to 5, okay? So this is my point x equal to 5. So lf of x at x equal to 5 will be the linear approximation of this function fx at point x equal to 5. Is it clear?
Yes, sir.
So at point x equal to a, the linear approximation is given as f dash a x minus a plus f of a, right?
Yes, sir.
This is the equation of tangent at that point. So similarly, at point x equal to 5, so this a is now 5, right? This a is my variable here. So now a is my 5 at x equal to 5. So this will give us f dash 5 x minus 5 plus f5. Clear?
Yes, sir.
So similarly here also, we have done same thing. At t equal to a, this is my linear approximation. Now my a is 1. At t equal to 1, I have to calculate, right? So at
So,
t equal to 1, it is nothing but f dash 1 into t minus 1 plus f of 1, right?
yes, sir.
So at f dash 1 we have calculated and f1 we also calculated. F dash 1 is minus 1 and f of 1 is 1. So I just put those values here and I am getting minus t plus 1 plus 1. So this is 2 minus t. Is it clear?
Yes, sir.
Is it clear, no?
Yes, sir. So there was this variable confusion, I think.
Yeah. I think you are just confused with this variable t and x.
So can I ask a question?
Actually, okay, actually there is a typo. This should be t. These all should be t, okay? This is 2 minus t, minus t, 2 plus t, and minus 2 minus t. Okay?
Yes.
So can I ask a question?
Thank you, sir.
Yeah, okay. Yeah, sure.
So solve with us question number 3.
I mean, solve with us, the answers are given here, right?
No, I did not understand the hint. Like, what exactly do we need to do here?
So this is again a piecewise function. So for x greater than 0, when x is strictly greater than 0, the function is x by tan inverse 2x, right?
Yes.
And this function is already continuous. Okay? So only problem arises when x is equal to 0, because for 0 there is a breaking of this function, right?
Okay.
So if at all the problem arises, it will arise at x equal to 0. So you have to enough to check the continuity at x equal to 0, right?
Okay.
Okay. Now when I am approaching from the right side, so let me write this function here. Can you read it for me?
1 minute.
Yeah.
Now x divided by tan inverse 2x
Okay.
when x is greater than 0. B, the second is B if x is 0. The third is sine of ax divided by x is if x is less than 0.
Okay. Yeah. So when I am approaching from the right hand side of 0, that is x is positive, right? Then what will be the function? When x is positive, the function is this one, this piece,
Yes.
right?
Yeah.
So what will be this limit? I have to calculate, right?
Yes.
Okay. So the hint is given about this thing, right? Some hint is given.
Yeah.
What is given? Limit x
It's
tends to 0, x by tan inverse x, right?
yeah.
It is given as 1.
Yes.
Okay. So this limit is 1, right? So I can write this as 2x by, so I am multiplying 2 on numerator and denominator. Is it okay?
Yeah.
Okay. So why I have multiplied this? So this denominator plus, so half I can take outside, and I am getting this function 2x by tan inverse 2x. Now as, so this is in this form now, right? In this form.
Yeah, is equal to 1.
So this is equal to 1 because as x tending to 0, this 2x is also tending to 0. So I can take my 2x to be y. So this will give me, so let me write it. So this is half limit y tending to 0 plus y by tan inverse y. I am taking y to be 2x. Is it okay?
Yeah.
Just change the variable. So this is 1. So this is half. Clear? So my right hand limit is half. Now what about the left hand limit? X tending to 0 minus fx. Now what about the left hand limit? It is sine ax by, for when x is negative, right? So sine ax by x. So limit x tending to 0 minus sine ax by x, right? Now you know that limit x tending to 0 sine x by x is 1, right? This you know.
Yeah.
Yeah. So I can multiply a on numerator and denominator, and I can take this outside, so that it will left me with sine ax by x, right? So again I can take my
Yeah.
y to be ax, so this is sine y by y. So I have taken y to be ax, this change of variable. So this is 1, so this will give me the limit to be a. So my right hand limit is half x tending to 0 plus fx, this is half. My left hand limit is a, and what is f0? F0 is b. Now for f to be continuous, this all three should be equal,
Yes.
right? Because this should be equal, this left hand limit and right hand limit should be equal to limit to exist, right? This is to exist, and this limit should be equal to exact value to be continuous. So this is my half, this is a, and f0 is b. So a equal to b equal to half will assure the condition for which this function is continuous. Is it clear?
Yeah. Yes. Thank you. Thank you, sir.
Yeah. Yeah. Okay.
Sir, can I ask a question?
Yeah, sure.
So my question is from activity question 2.3, question number 6.
Activity question
2.3, sir.
Okay, 1 minute. Question number?
Question number 6.
This I have started with today. I have already
So I am
explained this.
trying to. Sir, I have a problem in option number 1. So, sir, how can we evaluate the limit of this function?
Okay, so the question was whether you can apply L'Hopital's rule or not, right?
Yes, sir.
Yeah, so when can you apply L'Hopital's rule? There are two conditions,
Sir,
right?
yes,
At
sir.
first, it has to be an indeterminate form.
Yes, sir.
Indeterminate form, and this limit should exist.
Yes, sir.
And this limit should exist. This limit of f dash x by g dash x. This also should exist. This is the second condition. Okay. So yeah,
Yes,
when
sir.
we are calculating this limit, when we are seeing this function, this is obviously infinity by infinity form, so it is in indeterminate form. That is okay, right?
Yes, sir.
Now, so we go to the next step. We calculate f dash x and g dash x. So my f dash x is 1, my g dash x is 1 plus cos x, right?
Yes,
So
sir.
now my new function. So basically, I have to calculate this thing now, f dash x by z dash x. We have to check that this limit exists or not,
Yes,
right?
sir.
So this is 1 by 1 plus
Yes.
cos x. Now, my point is this is an oscillatory function, right? Because cos x is oscillatory function. I mean, cos x lies between -1 to 1. So this is the
-1 to
graph.
1. Yes, sir.
Yeah, this is the graph of cos x look like. Okay. So 1 plus cos x will
Yes,
be,
sir.
I mean, oscillate between 0 and 2, right? If cos x oscillate between
Yes,
-1
sir.
and
Yes,
1,
sir.
then 1 plus cos x will oscillate between 0 and 2,
0 and 2. Yes, sir.
right? It is just shift
Yes,
in
sir.
y-axis, positive y-axis by 1, right? So it will be in between 0 and 2. Okay.
Yes, sir.
Okay. But still, it is an oscillatory function. So this function, this oscillatory function can converge to a single particular point, any point. Suppose the function is oscillates, then can it
Yes, sir.
converge to some point?
So,
I mean, say, suppose I am saying cos x. Can cos x converge to some point as x tends
converse,
to infinity?
sorry, I'm not.
No, my
Yes,
point
sir.
is as x is increasing. So this is my cos x,
Yes,
right?
sir.
This
Yes,
is
sir.
cos x, like this. Okay. So this is my cos x. So as x increases, x tending to infinity. That means as x increases, will this function converge
Yes,
somewhere? No, right? Because it always
no.
oscillates. If at
Yes,
x
sir.
it
No.
is some point, then again x plus 5, it will return to that point. And in between it oscillates, right? So it
Yes,
cannot
sir.
converge to a single point. So this is the oscillatory function 1 by 1 plus cos x, and it cannot converge to a particular point as x increases. So the limit of this function does not exist, right?
Yes, sir.
Okay. So this limit extended to infinity, f dash x by g dash x does not exist. So clearly the second condition of L'Hopital's rule is not satisfied, right?
Yes, sir.
Moreover,
Yes, sir.
this function is now not in indeterminate form because it is 1 by something. It is not in indeterminate form, right?
Yes, sir.
So we cannot apply L'Hopital's rule again. I mean, we cannot go to the second derivative. That is also not possible. Moreover, this limit does not exist. So L'Hopital's rule cannot be applied on the given function. Is it clear?
Yes, sir. Okay, sir.
Sure, no?
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Yeah.
I have a doubt on this question.
Huh.
Hello. Sir, am I audible?
Yeah.
Sir, I just want to know the basics of these tangent and continuity. I'm stuck between the two. Can you explain me with a graph of x square, sin x, and cos x as to
Okay.
tangent?
So my first question is, have you seen the tutorial videos of week 1 and 2?
Yes, sir. Yes, sir. Maybe
So in
I
tutorial videos, I think
understand some
I have mentioned how these things are related, right? Using graphs.
the graph like a simple
Huh, huh, huh.
slight idea about these things.
Okay.
Still, in some examples,
Okay, I will then explain that. Yeah, someone else also was saying something. Who was that?
Yeah, yes, sir. I am the one. I am Srinath
Yeah,
here. On the
yeah, yeah,
previous question, the 1 by 1 plus cos x limit extends to infinity.
yeah,
But the limit exists between it is it's an oscillatory function within a band. It's like it oscillates between two and another. So there is a
yeah.
limit exists now between 2 points. So how do you say limit doesn't exist for x
No,
tending to
functional value
infinity?
is
There are
in
two
between
points
0 and
within.
2. See. Functional
Okay.
value is between 0 and 2. That does not mean that limit exists. Why that limit exists? This is a bounded function. That is okay. But why limit exists? Limit
The
means limit
problems
existing.
related to limit only is little confusing, sir. The limit based problems are little confusing to arrive at the solution.
Okay. Okay. Let me ask you one question
Like,
first.
no, not
Yeah,
about this problem.
I am addressing both of your questions, right?
No,
Tangent,
generally I'm saying like
continuity,
limit extends to 0 plus, limit extends to 0 minus. Those kind of questions, it's little hard to arrive at the limit, the solution for the such problems. Maybe,
are you there in this live session from the beginning?
no, I just came in between, sir.
So
I just
today I
joined
have
late.
explained only
Okay,
this kind of thing, as you can see.
okay,
Okay,
I'll go back and
so yeah, you just go back and check it. Okay, so I will ask
okay,
you
sure.
one question. You are saying about oscillatory thing. So suppose I am taking this sequence 1 minus 1, 1 minus 1, and so on. So that means my an is 1 if n is odd, and it is minus 1 if n is even. Okay.
Okay.
Now, can you say what is limit n tends to infinity? Can you say it?
Okay.
Huh. N tends to infinity
There's
means
not a
as
one.
n
There's not one increases. value.
Exactly.
There is
That
no
is
one
same thing about cos x.
value. It converges. Yeah, it converges
Exactly.
into two values. It doesn't
No,
converge
it does not converge
to
at
single
all.
value. Okay.
It does not converge at all. It is bounded between these two values. It is
These
taking
two
1
values.
or minus 1, but
Okay.
there is not exactly a single point where all the values converges. When
Okay.
I am taking 1 by n, this sequence, that means it is converging towards 0. As we are going, as n increases, we are getting towards 0. So there is a particular point to which all the functional value is approaching to. But in case of this kind of sequence, this oscillatory sequence, there is not a single value to which the functional value converges as n increases. Suppose a 1 lakh, that is a 1 lakh is minus 1, but at a 1 lakh 1 is again 1. So there is not a
Yes.
single value to which this functional value converges, right? So these are called
Okay.
oscillatory sequence. Similarly,
Okay.
for cos x, as x tending to infinity, as x increases, this cos x does not converge to a single value because cos x is always
Single
an
value.
oscillatory function. Got
Okay.
it?
Okay. Thank you.
I think now it's clear, right?
Yeah. It doesn't converge. It should. You say
Exactly.
the word converge. It should be only one value.
Exactly. There has to be one value to which all the function value should converge. But here
Okay.
function value oscillates between,
Yes.
for cos x is between minus 1 and 1. For 1 plus cos x is between 0 and 2. Right? So the function value oscillate between that. But there is not a
Okay.
single point to which all the values converges. right? It always oscillates.
Yes, yes.
When x increases, we will get another value. That value is in between 0 and 2. That is okay. But it does not converge. It is bounded, but it does not converge. Okay.
Okay. Okay. Thank you.
Okay. And yeah, so question about this tangent and continuity. So can you say me? Okay, let me show you that. Okay. Suppose I am taking x square. So start with a easy function. So yeah, who was asking that question?
Sir, it was me.
Yeah. So can you tell me what is the tangent at x equal to 0 for x square?
So this line, this horizontal line, the x-axis line.
So it is x-axis. Now if I take, so okay, suppose I am taking now x equal to 1. So you can see that how the tangent will behave when the point changes. Okay. So at x equal to 1, the tangent will be this line, right? And when we are coming from x equal to suppose -1, the tangent will be on this side. So this slope of the tangent is nothing but the derivative of the curve at that particular point. Okay. So that is one of the definition of derivative. That's how we are interested in calculating that derivative. So before going to derivative, we first calculate limit of that function at some point, at some particular point. Suppose I am considering x equal to a. So at first we have to calculate the limit of the function. So limit of the functions means, suppose I am calculating from the right hand side of that function, approaching from the right hand side to a, and approaching from the left hand side to a, and these two should be equal. If these two should be equal, then limit of this exists. So this is the first point. Limit should exist. Then the second point is, if this limit, if this exists and it is same as the value at that point. So at x equal to a, the function has some value, that is f of a. If this happens, then we say that f is continuous. Now
The tangent and both the values are same. Slope and
that I will come. Okay. So after that, if this limit exists, then we say that f is differentiable. So, and this is called the derivative of the function at the point. So this is derivative of a at x equal to a at that point. Now what I have said earlier in the graph, that this derivative is nothing but the slope of the tangent at x equal to a. So for the function fx, there is a point a comma fa, and at that point the slope of the tangent is nothing but f dash a. So the equation of the tangent, so the tangent is a straight line, as you know, so that will be, so I am writing it at tfa at a, equation of the tangent, it is nothing but f dash a into x minus a plus fa. So it has to satisfy this point a comma fa. So you can see it is satisfying that point, it is going through that point, and the slope is nothing but f dash a. So it is the slope of that tangent. So that's how slope, continuity, and derivative of a function are related. Now this is the why this is slope. So suppose this is my function. Okay, so this is my a. So this is x equal to a. Now suppose this is my a plus h. So this is a plus h at x equal to a plus h. So this will show the increment of the function in between this interval, right? So this is f of a plus h. This is f of a, right? So this is the change in, so this is f of a plus h minus fa, this part, and this part is h. So this by this is nothing but tan of this angle, right? So that is basically the slope of the function in this interval. Now as we are taking h nearer to 0, that means we are coming closer and closer to a. So that's why we are taking the limit. So this will give us the slope at that point. Is it clear?
So while we are taking the right hand side or left hand side, we are
Huh.
putting the variable as infinity.
Infinity.
Some of the example, like one of the example I
Some of the
wrote, like
example there is infinity. Yeah.
like
Okay.
1 upon 1 plus e raised to power 1 by x. So
Ha,
we were
ha.
placing x as minus infinity or plus infinity.
Okay. Let me see. So at first your question is why we are taking these two limit, right? Extending to a plus and extending to a minus. What is the?
But interpretation these like how the
Yeah.
values are exactly a plus and a minus.
Suppose I am taking this function fx. Okay. So this is my point A. So this is f of a. Okay. Now the limit of this function means when x is going towards a, what will be the value of this function? Now we can go towards a from this side also and this side also, right? From both sides we can approach to a, right? So the limit of that function at that point x equal to a will exist only if these two limits should is equal. Otherwise what will happen? Otherwise we will arrive into the case, suppose this and this.
Discontinuity.
Suppose I am approaching a from the left side, then I am getting towards this value, and I am approaching a from the right side, I am getting this value. So the limiting point does not match for both this case, right? So in this case, limit extending to a plus fx is not same as limit extending to a minus fx, right? So this is right hand limit, this is left hand limit, and these two are not equal. Okay, so we cannot say that limit at x equal to a exists. So there is some discontinuity at that point. Okay, so when we are considering the tangent, see, when we are considering the tangent at x equal to a, so the tangent will move like this and coming like this at this point when we are approaching from the left side. But when the tangent is coming from this side, it will be like this. So at that point at x equal to a, this tangent is not unique. I mean, slope of the tangent is not unique. So we cannot say that in this point of discontinuity, the tangent exists. So if there is a point of discontinuity, then at that point, there is no tangent of that function. Is it clear? So when there is a discontinuity, the function is not differentiable. And as it is not differentiable, there cannot exist any tangent at this point. So that's why this right hand limit and left hand limit are important. Am I clear?
Yes, sir. Sir, I have
Yeah.
said square. One is mod of x. Mod of x is a taper is at the like two triangles meeting at a point 0.
Fx is mod x, right? Yeah. Can you repeat? Can you be a little louder?
Sir, mod of x, like it's like a tangent, like a inverted
So the
triangle.
graph will look like this.
Yes, inverted triangle sort of.
Not a triangle. Okay. I mean, graph will look like this, right?
Yes, zero. So zero, there's an abrupt change.
Yeah. Yeah.
So is this function, we say, we have a tangent at zero, and is it continuous? Because
No. So this function is continuous at 0. This is continuous at 0, but it is not differentiable.
but it is not different because it does not have tangent at zero.
Yeah, exactly. Because
Sir,
when we
how
are coming
can
from this part, the slope of the tangent will be like this. When we are coming from this portion, the tangent will be, slope of the tangent will be different. So at 0, the slope does not match. So the tangent cannot exist at that point. So the function is not differentiable at that point. Is it clear?
tangents are two different lines which are crossing each other, so that's why this tangent are there.
So there is no unique slope of that tangent at that particular point. Okay. So that's why we are calculating the limit basically. So for differentiability, so what is this function first of all? So fx is x when x is positive, and it is minus x when x is negative, right? This is the function. This is mod x, right? Hello.
We can yes sir, so we can conclude that whenever there is an abrupt change of something, the values, so function would be differentiable and the tangent will
When
not
there
be.
is a sharp corner like this, sharp change, then the function is not differentiable at that point.
But it is continuous. It is continuous.
I mean, you can, in this case, it is continuous. You can go via this one. See, what is the definition of continuous? If x tending to 0 plus, what is fx here? If we are approaching from the positive side of 0, what is the value of this function?
About zero.
0, right? Because for x greater than 0, the value of the function is x. When x is less than 0, the value was minus x, right? That is the mod function, basically. Right? Hello?
Yes sir, yes sir.
Your voice is very low. I cannot hear you properly. Yeah. So when x is coming from the negative side, from this left hand side, what is the value of this function? This is again 0, right?
Yes sir, yes sir.
Yeah. So these two limit is same.
For negative function, it's 0. So for the negative function is only x less than 0. So it will be like minus 0.1, minus 0.2
This is
maximum.
x approaching to 0. What is f approaching to 0? When I am coming from the left hand side, if I am approaching to 0, what is the value of the function approaching to?
Function would approach towards like.
No, for the previous one, I understood. For x greater than or equal to 0, when we are approaching to 0, x equal to 0, because x can take the value 0 because it's greater than or equal to. But
This
here
is not.
x is strictly less than 0. Strictly less than 0.
See, 1 minute. X tending to 0 does not mean x is taking the value 0. This is different. That's why these three notion is there. These three notions are different. X tending to 0 mean we are approaching to 0. So this is 0. We are approaching to 0 from the positive side. That does not guarantee that x is taking the value 0. Okay? When we are approaching towards 0, what will be the value of the function approaches to? That is the limit. That does not imply that value at that point itself. Okay? Is it clear? That does not imply the value of the function at the point x equal to 0. That may not happen.
This case when.
Okay? See, here you can understand better when what is this thing basically. Limit extending to 0 plus fx. So suppose my x is half. Okay, what is the value of fx? What is the value of fx? Hello?
It's half.
Yeah, half.
Half.
Exactly. When x is 1 by 3, what is the value of fx?
Say 1 by 3.
1 by 3, right? Yeah. So when we are approaching towards 0 like this, so half is more closer, sorry, 1 by 3 is more closer to 0 than half, right? So fx is, for fx, this 1 by 3 is more closer to 0. So as we are approaching towards 0 from the positive side, the value of the function also approaches towards 0 from the positive side. Okay, that's why this limit is 0. Similarly, from the negative side, suppose x is minus 1 by 2. What is our fx? It is again half. X is minus 1 by 3. It is again 1 by 3. So as we are approaching from the negative side towards 0, so here it is 0, it is minus 1 by 2, minus 1 by 3. Here it is minus 1 by 4. So functional value will be approaching towards 0, right? For minus half, it is half. For 1 minus 1 by 3, it is 1 by 3. For minus 1 by 4, it is 1 by 4. And that's how, when we are approaching from the negative side of 0, the functional value also approaches towards 0. That's why the limit extending to 0 minus fx is 0. Is it clear?
Yes, yes.
Now what is f of 0? What you are telling? At x equal to 0, this is nothing but the first part, this portion, x is 0. So this is 0. So all these three matches. The limiting value from the right side, the limiting value from the left side, and exact value at 0. These three matches, that implies f is continuous. Clear? Is it clear?
Yes, sir. Yes, sir.
Okay. Now for differentiability, you have to check at x equal to 0. So h tending to 0 plus f0 plus h minus f0 by h. So this is nothing but fh. Now f0 is 0. So fh by h. Now what does it mean? It means it is 0 and h is from the positive side. H tending to 0 plus means h is coming from the positive side, right? So from positive side, the function is nothing but h. Fh is nothing but h. So it is h by h. So it will give us 1. H will cancel up. So it is a constant. So that will give us 1. Now, what if we approach from the negative side? So from the negative side, if we calculate it, it will be limit h tending to 0 minus fh by h. Now fh is, as it is from the negative side, it is minus h, right? Because we define the function like this way. This is our mod function. So when h is negative, so it will be minus of h, right? So it will be minus h by h. So h will cancel up. This will give a minus 1. So these two value does not match, right? So the slope, when we are approaching from the right side, the slope will be 1. When we are approaching from the left side, the slope of the tangent will be minus 1. So at 0, the slope does not match. That's why at 0, the tangent does not exist. So the function is not differentiable at that point. Am I clear?
Yes, sir. Yes, absolutely.
Hope it will help, I think. This will
Yes,
be
sir.
the main concept of limit, continuity, and differentiability.
So,
Okay.
can sir, can you please solve activity 3, question 5?
Okay. So I think it's already time. So this is the last question I am taking. Okay. Activity question 3. This one.
Activity 3, question 5.
So this one basically log x
Yeah,
base
log.
5. So this is easy, right? Why have you problem in this one?
I thought the formula was 1 by x of derivative, but I don't.
That is of log x, right? Log x. So if fx is log x means this is log e base x, right? So for this, the formula is 1 by x. Okay. Now here it is given log 5, sorry, log x, and this is 5, right? So this is our fx. So at first you have to write it in log e base 5 and log e base x, right? This is your function, which is nothing but ln 5 by ln x. right? So this is constant, log 5 is constant, so this is some constant by log x, this kind of function, right? So if you take the derivative, the
Yes, sir.
constant will remain as it is, c, and so this is 1 by log x, so 1 by, so minus log x square 1 by x. Is it clear?
Yes, sir.
So for 1 by log x, this is the differentiation, and then you have to differentiate log x. That will give you 1 by x, right?
Yes, sir.
And this c is basically log of 5. So what you got? You got this thing. Okay. So you just write it and check which option it matches with.
Thank you, sir.
Okay. You just check it and check which option is matches with. I mean, it is nothing but log 5 x. This is log x and log x. So minus 1 by x can be remain as it is. So it will give you log of x base 5 and 1 by log x. I mean log ex. So you now matches with the option. Okay.
Yes,
Is it
sir.
clear? No.
Yes, sir.
Okay.
Thank you
Okay.
so
So
much, sir.
So let us stop here. So is it clear? I mean, what I have discussed today.
Yes, sir.
Okay. So okay, I will stop share now. Okay. Thank you. Good night.